Now that we have discussed about linear equation in two variables x and y, let's now investigate on the solution of the linear equations. What could be the possible solutions for the given linear equation is what is the next investigation process in the coming topic. So let's see solution of linear equation. Of course, here dealing with the two variables x and y is what is the topic of the session. Solutions, as we know, are the values which satisfy the given equation, in this case being linear equation. So let's see what are the values which satisfy this equation in brief. So before we come to the understanding of the concept more stronger, let's investigate through various example problems. For example, I take 2x minus 6 equal to 0. I clearly see this to be degree 1 and degree 0. Therefore, this is a linear equation, but the number of variables is x. So this being an equation, this is an example of a linear equation in x, in one variable x. So let's recap with the linear equation in one variable and then try to understand the solutions of a linear equation with two variables x and y. So with the example problem which involves a linear equation in x, say for example 2x minus 6 equal to 0, let's see what are its solutions and how these solutions help us in understanding the solutions of the linear equation in two variables. As we can see clearly, the given equation is 2x minus 6 equals 0. Its solution is about nothing but the value of x which satisfies this equation. So let's see what value of x satisfies this equation. Clearly, when you want to identify the value of x which satisfies the equation, it's nothing but about simplifying this equation to get x. Therefore, in order to find x, I take all the x terms to the left and all the non-x terms to the right. So minus 6 does not have x, so it comes to the right as 6 plus 6. Then I have my x, which is 6 over 2, 6 by 2, because 2 comes down here, and then on further simplification I get this to be 3. Therefore, x equal to 3 is said to be the solution of the given linear equation. Is how we understand the solution. Therefore, x is equal to 3 is the solution of the linear equation in one variable x, that is 2x minus 6 equal to 0, is how I conclude. So how do we justify this in two variables x and y? For a linear equation in one variable, we can find the solution through the simple process by just evaluating the value of x, and that value of x acts as the solution of the given linear equation. But what about a linear equation in two variables x and y? So let's investigate a linear equation in two variables x and y with its solutions. So let's take an example problem of a linear equation in two variables x and y. For example, I have 2x minus 4y minus 7 equals 0. And this is clearly a linear equation in two variables because I have the variables with first term being 1 and the second term degree being 1 and this being 0. Therefore, the highest degree is 1. And clearly with two variables x and y, this is an example of a linear equation in x and y. So this is a linear equation in x and y. So let's see how we can find the solutions for this x and y. As we take here 2x minus 4y minus 7 equal to 0, let's see if we can find the value of x and y which satisfy this equation. Unlike the previous example which we have taken in the previous session, which is a linear equation in one variable x, and let's compare the solutions of the two equations. Now, as we know here, clearly I can find the value of x by taking the constant to the right and then taking 2 down, and then I get this to be the solution. Let's see if I can use the same process for my linear equation in two variables x and y. So proceeding similarly, I get this to be taking the constant to the right, as I've taken 6 to the right on the second equation, taking minus 7 to the right, I get 7, and then let's see if we can find x and y. But again, I have the variable y, which cannot be evaluated when you have the variable x. So here I clearly understand that when I have an equation in one variable, it is easy to simplify and get the solution. But when I have two variables x and y, it is not possible to find the solution x and y for this equation. Therefore, let's see how we can find the solutions of this equation in a more simplified manner. Linear equation in two variables x and y cannot be solved as we can solve for linear equation in one variable x. Can be solved, cannot be solved. So let's see what are the terms or the limitations in solving a linear equation in two variables x and y, unlike the linear equation in one variable x, which can be solved by simple mathematical process. Now let's take an example problem to understand why it is not easy to solve the solutions of a linear equation in two variables x and y, unlike for a one variable x. So here comes the example in which I would like to solve the equation x minus y equals 1. This is clearly a linear equation in one variable, in two variables x and y. When one brought to the left, it can be equated to 0. Therefore, let's see how we can solve this. Now, before we solve, it is very important to note that solving is about finding the variables. Solving is about finding x and y in this case. So we need to know what exactly x and y stand for. So in order that we need to solve this equation x minus y equal to 1, the condition is to find x and y which are real numbers. That is, we are searching for the real numbers which satisfy this equation. To find x and y which belong to real numbers is what is the target. So let's see how this target can be achieved. In order to find x and y from the equation, unlike the general mathematical process, let me try with trial and error method. Let me try with the hit and trial method. So in this hit and trial method, I first take x equals 2 and y equals 1. And let's see if this satisfies the equation. Clearly, my left hand side, which satisfies x equal to 2 and y equal to 1, is equal to 1, and which satisfies. Therefore, one set of solutions is x equal to 2 and y equal to 1. Let's try another hit and trial method to find the other possible solutions for this. Let me take x equals 3 and y equals 2, and let's see if this satisfies the given equation. My x equals 3 and y equal 2 implies my left hand side, which is 3 minus 2, x replaced with 3 and y replaced with 2. And we know that 3 minus 2 is 1. Therefore, even this set, because it satisfies the given equation, is said to be the solution set for the given equation. Let's try with another example. x equals 9 and x equals 8, and let's see if this is the set of solution. Substituting for x as 9 and y for 8, 9 minus 8, which is 1. Therefore, this also satisfies the given linear equation. So as you can see, there are many solutions. Like even if I take a very random number like 9,999 and I take y as 998, also equally when I replace, I get the solutions as 999 minus 998, which is equal to 1. And therefore, I get the possible solutions for x and y being 999 and 998. It continues and continues, but there is no end to the solutions for this equation. So what does we learn out of this example problem? When we see the example problem x minus y equal to 1, as we see the different sets of solutions for x and y, the different sets of solutions for x and y, all satisfying the given equation, they are all the solutions. This is a solution for the given equation. This is also a solution for the equation. This is also a solution, and this is also a solution for the linear equation x minus y equal to 1 in two variables x and y. So what do we understand? For a linear equation in two variables x and y, there are infinitely many solutions, is how we conclude with the given problem. So my learning outcome is a linear equation in two variables x and y has infinitely many solutions. The learning outcome of a linear equation in two variables x and y, it has the endless solutions, infinitely many pairs of x and y, as seen with the example problem, unlike the linear equation in one variable which has a unique solution. So we finally conclude a linear equation in one variable has a unique solution, and a linear equation in two variables has infinitely many solutions, cannot be unique.
If you like this video, please give a thumbs up. Please subscribe to our channel to get more videos on CBSE syllabus.